Recording in progress. Hi friends, in this lecture I am going to discuss it is how to calculate strength of the gravitational field. So in this we are going to calculate due to point mass, then thin wire of uniform linear mass density. After that, due to circular arc at center of curvature, and then at a point on the axis of a ring. Okay, let us see now field due to point mass. Right. So we want to calculate now field due to point mass. Imagine there is a point mass. Its mass is m. We want to calculate now at a distance r. What is strength of the field? Distance equal to r. Okay. So whenever we want to calculate strength of the field, at that point we have to imagine a unit mass. We have to imagine unit mass. Then gravitational force acting on that gives strength of the field at that point. It is a unit mass 1. Okay. Because we are knowing that F bar equal to M into G bar. If mass is 1 unit, then force is equal to G bar. Or you can say G bar equal to force. Because we know how to calculate a force by using Newton's universal law of gravitation. Okay. So here we are calculating force by this unit mass, by this point mass on this unit mass. And that force gives us strength of the gravitational field, right? Say force how much? It is equal to G m1 m2 by square of the distance r square. Okay. This is giving us modulus of force, or I can say it is modulus of G bar. But if you want vector form, then see what happens. This is attracting, therefore it will be now towards point mass. That means I have to write here minus r cap. See carefully. G m1 m2 by r square modulus value. Direction is opposite to r bar. So r bar is now like this. Position vector of that unit mass with respect to point mass. It is towards right side. But force is left side, means opposite to r bar. That's why I have taken here minus r cap. This is intensity of gravitational field, or we can say strength of the gravitational field due to point mass, right? That is the first one. Now second one is thin wire, uniform linear mass density. See how to calculate. Let us take a thin wire. We want to calculate now strength of the field at some distance r from the wire. And when we join the ends of the wire to that point, joining ends of that wire to that point, they make angles. They make angles alpha and beta. Okay. And let us take here lambda is mass per unit length, which is uniform, means which is a constant. So we have to get G value in terms of alpha, beta, and R. Okay. Then see what we can do here. So first we consider, let us take at some distance x from this line, okay? At some distance x, take element of length dx. Element of length dx. So whenever we want to calculate the strength of the field, at that point we have to imagine a unit mass, okay? Now, why we are taking small element means, if you want to apply Newton's inverse law of gravitation, there must be 2 point masses. This is no point mass, but this is not a point mass. So to get a point mass, we are taking a small element, okay? Now having 2 point masses. Now this point mass is attracting this point mass, right? And that will be along the line joining them. See carefully. Just draw one line from there to. So drawing one line. I join once those 2 points. From this point, the diagram is not correct. Let me draw once again. Otherwise, take diagram separately. Right. We are taking here at some distance x element of length dx and join that point to this point. Suppose this makes angle theta with that line. Okay. This is now x. Then see force will be along the line joining them. Force will be along the line joining them. Along the line joining them. That is now gravitational force. It is I'm taking as G. Or you can say because of small element it is dg. Okay. That value will be dg, that is equal to g m1, that is 1, m2 lambda dx, g m1 m2 by r square. R square means this is r and this is x. Distance will be square root of x square plus r square. So taking here x square plus r square. See once again, it is equal to g m1 m2 by r square, square of the distance, right? Now it is having two components. One is normal to wire and one is a parallel to wire. To get normal component, let us take here calculation. Let us take it is now g perpendicular, that is equal to integration of, see taking the component is of dg cos theta, dg value g lambda dx upon x square plus r square into cos theta. And see what is the value of, okay, leave it to take cos theta only into cos theta. Now we have to integrate this one. If you observe carefully, alpha is now measured clockwise, beta measured anti-clockwise. So if you are taking now clockwise a positive, anti-clockwise will be negative. So this convention is completely our choice, okay? So if you take anti-clockwise negative, clockwise positive. Or if you take anti-clockwise positive, clockwise will be negative. So if I'm taking clockwise negative, it will be from minus alpha to beta. Okay. So what we have taken here, anti-clockwise as positive. And if you see result carefully, here x is variable, theta also variable. So we want to convert this into single variable. Then see how to connect now x, and theta. From this diagram, we can say tan equal to, so tan theta equal to x by r. Okay, so x by small r, x by small r, and here we want now dx. Okay, so if you want dx, we have to differentiate this. So differentiate that dx equal to, since r constant, it is r into secant square theta d theta. Okay, now substitute that in the above equation, then see what we get. Right, let us take calculation here. So in the place of dx, r secant square theta d theta, here if you observe, in the place of x, writing r tan theta, r square tan square theta, taking here r square outside, r square into 1 plus tan square, it is secant square, right? So this will be now becoming, after substitution, it becomes now g normal is equal to g lambda by r, remaining is integration of cos theta d theta. Okay, after substituting that and limits minus alpha to beta, integration of cos, it is a sine. So g lambda by r sine beta minus sine minus alpha. This is now the normal component of g. Okay, and if you want to calculate parallel component, see where change comes. In the place of cos, we have to write it is a sine. Okay, that means everything as it is, only change is now it is a sine. And when you take a sine here, we get minus cos. Okay, minus cos means it is g lambda by r, minus cos means it will become cos alpha minus cos beta. Okay, like this we can calculate g normal and g parallel. That means one component is normal to wire and one is a parallel to wire, like this. This parallel one may be up or may be down, which depends on the values of alpha and beta. Then we have take now resultant. Okay, see next one. Field due to, sorry, second is over. Yes, third one. Field due to circular arc at the center of the curvature. Right. So we are taking one circular arc, taking a circular arc. Join the ends. Join the ends. Let us take this makes angle theta at center of curvature. Angle is theta. Radius of curvature is r. So we want to calculate now at center of curvature. Let us take lambda. Lambda is mass per unit length. Then see how to calculate. So first I'm taking here one line of symmetry. I'm taking here line of symmetry. If you remember how we have done calculation for center of mass. Okay, we have taken the same process. From line of symmetry, we have taken some angle, some angle. So take it as alpha. Take a small change. Take a small change. It is now d alpha. Take a small change. It is not d alpha. So here we are imagining one unit mass. Okay, it is one. This is now one more point mass. Its length will be r into d alpha. Okay, and that will be along the line joining them. It comes like this. Okay, I'm making diagram separately here once again to make it clear. Symmetry line, and we have taken like this angle is alpha. Small changes d alpha, very small. So that g will be like this. Take it as it is now dg. So g value because of that small element dz. Okay. Now we can take here two components for g. See, one is, if you call it as x-axis and this is y-axis, that line of symmetry. So take one component along x, another is now along y-axis. Okay. So what is of this component? This x will be dg, or its x component is equal to, see what is the value? G m1 m2. M2 is now lambda into r d alpha. G m1 m2 by r square. Distance is r, right? R square. Its x component is now into sine alpha. Okay. And if you see, if you want to integrate integration of sine alpha d alpha, it becomes now cos alpha. And we have take limits now minus theta by 2 to theta by 2. Okay. So cos of theta by 2 minus cos minus theta by 2. That means this becomes 0. So there is no field component along x-axis. It is only along y-axis. And see that value how much? So again we get same thing. Only changes in the place of sin alpha. We have take cos alpha. So it is now gy, that is equal to integral g m1 r d alpha g m1 m2 by r square into cos alpha. This is the only change, okay? So in this and in this only change is now taking cos alpha. So take here g lambda by r outside. Integration of cos alpha d alpha. It is sin alpha. So it becomes now sin alpha. Take limits. Sin theta by 2 minus sin minus theta by 2. Okay. That becomes now 2g lambda by r sin theta by 2. Okay. That means resultant strength is, it is along the angular bisector. Okay. So final value is 2g lambda by r into sine theta by 2. If you are given full circle, then theta becomes 2 pi. Then 2 pi by 2, it becomes sin pi. It is 0. So at the center of a uniform ring, g value 0. If you are given a half ring, then theta will be pi. Okay. See next one. Field at a point on the axis of a ring. Let us see last one. Field at a point on the axis of a ring. So first we are taking one ring. Let us take one axis. We want to calculate now at one point. Let us say distance equal to x. Okay, at one point we want to find strength of the field and take radius is r. Now see here what happens. Let us take one element on the ring. Okay, its a mass equal to dm. So first step, imagine unit mass at that point where we want to calculate strength of the field. Okay. Now this point mass will attract this unit mass, and that will be along the line joining them. And that will be along the line joining them. So I'm showing here it is like this. So take it as it is now dg because of that small element and that value dg equal to g m1 that is 1 m2 that is now dm by r square distance equal to r square plus x square under root. Okay. So g m1 m2 by r square, it is r square plus x square. And if you observe carefully, we can take one component along the axis and one is normal to axis. And if you take one more point diametrically opposite, it is diametrically opposite. This also attracts now with the same magnitude, and components normal to axis, they will cancel. Components normal to axis, they will cancel. The remaining is only along the axis. Okay. Therefore, net value will be g equal to only along the axis, and that is now integration of g dm by r square plus x square. Suppose this is now theta. It is now into cos theta. Cos theta means it will be x by hypotenuse. X by hypotenuse. X by hypotenuse means it is square root of r square plus x square. That means this power becomes 3 by 2. Okay. Now if you see carefully, in this integration, except dm, remaining all are constants. And integration of dm gives mass of the entire ring. It gives mass of the entire ring. Okay. Therefore, it is equal to g m x upon r square plus x square whole power 3 by 2. And direction will be, it is along the axis, which is towards the center of the axis. Okay. And you can see here, if x value 0, g value 0. If x value infinity, then also g value 0. That means from center to infinity, if you observe, at center 0, at infinity also 0. So in between, strength will increase and becomes maximum, and again it will decrease. Okay. So if you want to calculate, or if you want to know for what value of x g becomes maximum, then we have to differentiate that with respect to variable and make it equal to 0. Then we are going to get x equal to, it is r by root 2. Okay, it is x equal to r by root, or you can say plus or minus, because we get one point, okay, right of this one and one more on left of that, right? And how much means it is r by root 2. Okay.